I gave a talk very similar to this one like 3 weeks ago in DC. I was limited to 7 minutes. So 30 minutes is going to seem very expansive, especially there's no gong at this one like there was at that one as well, literally speaking. So I'll try to fill the time, but also I'm now standing between you and lunch, and that's not a fun place to be. So this is a side update, essentially from NCSA, what we're doing with Lustre. We ran Lustre with Blue Waters, obviously back in the 2012, 13 to 2018, 19 era. But during that time, other than that system, there was no other Lustre NCSA, and we had a lot of other file systems there, but we've kind of been bringing Lustre back for a lot of other things recently. And so we're going to touch on a couple of key file systems that we operate that are Lustre. There are others that I'm not going to really talk about much today, but these are the cooler ones, I guess, that we'll touch on here today. So just a brief overview. For those of you not familiar with NCSA, we're not the National Collegiate Sports Association, which is what Google would tell you we are. We are the National Center for Supercomputing Applications. We're on the University of Illinois campus. We operate the petascale computing facility. We have about 9,500 active users as of when I checked a couple weeks ago when I made this, and about 2,000 compute nodes in production. Right now, we've just kind of crossed over the 100 petabyte of storage capacity boundary, and we have about 7 billion objects under our control right now. So our major compute environments, just to kind of set the stage for where we are on compute-wise, we operate a system called Delta, and very soon a system called Delta AI. These are both NSF or NSF allocated systems for both access and soon to be NAIR as well. These are both HPE Cray systems that run various versions of NVIDIA GPUs and AMD CPUs on Delta. We also operate infrastructure for the University of Illinois system, and that has about getting close to 1,000 nodes in it now of CPU and GPU. Both varieties, it's a very mixed, heterogeneous system. We also operate a couple of clusters for industry partners that leverage our services. We run them because they don't want to run their supercomputers in-house. We also export these file systems to an OpenStack environment. We have a lot of researchers that are pushing into that direction for certain things that we'll talk about here in a bit. And we also operate ePHI, Secure Health Enclave, that's classified for CUI data and as well as ePHI data access. So we were designing our global file system Taiga a couple of years ago, which is the main focal point for this talk. We had multiple things that we wanted to kind of achieve. We had kind of had a center-wide file system before this, but it was only half center-wide in many respects. So we kind of set out to redo that here with this file system. And so we wanted something that was obviously easy to scale, both in terms of capacity and performance. We don't have extremely large budgets to procure storage with, and so we wanted to procure storage as we needed it in some reasonable form factor in chunks. So that was very important to us to be able to slowly expand the file system as we needed its capacity to grow. We definitely wanted to do something that was hybrid in terms of flash versus hard drive. Prior to this, we've done a lot of obviously metadata on flash, but data on disk. But we want to kind of branch out from that and get some of our data on NVMe as well. And the biggest thing that was about this that kind of differentiated it from our older global file system was that we wanted it to actually peer directly with every compute environment's high-speed fabric, which, as we'll see on a slide here soon, is a very heterogeneous environment as well. We needed a lot of quota support to control users' usage on the systems because, as we all know, they'll fill the space like a gas with whatever capacity you give them. And one of the big things that we're going to talk about also is that we need to support multiple authentication methods for this system. We don't just have a single user namespace that we need to operate within. And a big goal that we wanted to achieve here is that we want to prevent users from having to copy files between compute systems. We operate 6 or 7 main machines, and there's often users that have accounts on 3 or 4 of those machines. And we were seeing a lot of activity where people were using Globus to to move data between different supercomputers and their respective file systems within the data center. When we were running our Globus telemetry, it's like, wow, half our traffic is internal to the center. People just Globus copying back and forth. So we wanted to do something that kind of solved that problem because users copying data back and forth was just wasting their time having to do that when they didn't need to. So that was a huge goal of this system as well. So, this is a high-level architecture diagram. It'll be better in PDF, I promise, when you guys get that. But hopefully it's a little bit readable on the slide there. So this system is based on an HDR InfiniBand full 200 gig backend fabric at its core. This file system, we translate it, like I said, to every high-speed fabric of the clusters. On the right there, you can see we have different flavors of InfiniBand, different flavors of Ethernet, and obviously also Slingshot 11 in there as well. So a large number of fabrics that this file system has to translate to natively and do I/O and receive I/O from all those fabrics, which Lustre does pretty well at with LNet. We leverage LNet code extensively for that. We also have sets of worker nodes that we use for data packaging and migration. We operate a tape archive system that is distinctly separate from this, and there's a lot of work we do to help users migrate data into and out of the file system from tape when they need to, mainly to tape. But we have a set of nodes there off to the left that kind of run Robinhood and do a bunch of things to help them do that and package up data and get that work done. And right now we currently export this file system as well to NFS, via NFS for OpenStack access, and have a Globus shared endpoint, but we're also adding Samba here soon as well. This is the high-level architecture for that system. In terms of the actual storage itself, this was originally built with four 400 NVX storage units. These each had 8 OSTs that were disk-based and 8 OSTs that were flash-based. With those values that were on there, we expanded that about a year later and doubled that system size. By adding an existing 18K that we had on the floor, we actually converted a grid scaler 18K into an exascaler 18K and then brought that into the file system live. And then we're actually about to grow again, which is that now grayed out cylinder there that's coming online here soon. We'll be expanding with another 400 VX2 unit to throw another 5 or 6 petabytes on the system here for a reason I'll kind of bring up here in a moment. So, and this kind of lists out our storage targets. We tried to, as we did this, even though we have some slight heterogeneity in the controller architecture, we tried to keep uniform OST and MDT sizes as best as we reasonably could as we've grown the system out, just to keep performance and things kind of sane as we did that. We weren't quite perfect in getting the OST balanced in terms of size for the hard drives, but for the flash and everything else, we were able to keep that all very uniform. And we are leveraging Exascaler 6.3 with this, with hotfixes on top of that. So as of time of writing here, we're pretty close to the bleeding edge of Exascaler in terms of the code. So if anyone, I think Peter talked about earlier about people moving up in hesitancy, if we want to talk about somebody who's running on the leading edge of Lustre right now, we are fortunately or unfortunately at that point with this file system. So we can hopefully share some information there on that. We do use PFL to lay out data on this file system, coming from a lot of GPFS file systems that our users have. They are just not accustomed to having to manually set stripe and do things correctly. And so we knew we needed to do that right out of the gate when things started. That's also why we jumped on the Exascaler 6 bandwagon so early, is that we wanted to make sure that we were using DNE3 and round robining metadata across as best as we could from the get-go, because we knew that it was going to lay out fine on its own otherwise. So we have a PFL. I'm not going to read through it here, but we slowly ramp up where we keep the first part of every file on disk, on NVMe. With that 64 kilobyte capture size, we're actually capturing somewhere around 50 to 60% of files by file count completely in the NVMe tier. And then it progressively stripes out wider as we get bigger, all the way up to actually running we stripe across all OSTs at the largest layout. So we, by default, also set inode quotas and keep users within 1.5 million inodes per terabyte of allocation. But for certain pesky workloads, we do give exceptions up to 4 million. We're not currently running DOM or hot pools on this system. We do monitor it in-house with a custom TIG stack that we've built that monitors Lustre and Exascaler separately. And we have NFS exports right now, like I mentioned, but we're also adding Samba here soon. The biggest thing that we're kind of working through here right now is handling multiple identity systems. I mentioned that that was coming up here soon. We maintain our own LDAP structure. For NCSA, we support, like I said, 9,000 plus users, and those are from institutions all across the United States. Obviously, the University of Illinois would not be keen to us just injecting those users into its Active Directory system. And so we obviously maintain our own LDAP for a very long time. So that's what Taiga uses for its primary realm for authentication. But we're actually moving the system we moved for Illinois. It was hosted in another data center, and it's actually moving into the same data center as Taiga is currently located in. So we can now leverage Taiga with that system, as opposed to having it be its own separate bespoke file system that it had to have, which is good. So we get to consolidate down and leverage the extra capacity and performance of that. But we now have a collision because the infrastructure that we run for campus services relies on their Active Directory. A lot of this comes down to users, especially like grad students, undergrads, even postdocs and professors. They don't want to have to manage an NCSA identity versus an Illinois identity. They want to just have one identity to rule them all. But there's also some practical and technical reasons why it's also helpful. A lot of them, we Samba mount the file system out to them on request. A lot of times this is handy for workstations that operate large scale microscopes or instruments that are ingesting data straight off the scope. A lot of those large vendors don't do a good job of, like, I can't mount a Lustre client on there. And so we use Samba to do that as well. So that kind of helps them. And you need that for AD joined computers to be able to unify with their Active Directory structure there. So we're actually actively testing Lustre node map here at a decently large scale, because obviously the UIDs and GIDs between these two systems align. As a university employee, my username is the same across both systems, but my UID obviously is very distinctly separate. There's no coordination that's gone on historically there. And so we'll be using node map to do this. Initially we did a first pass. I think 2 weeks ago, we identified that we're going to have to map about something like 3,500 users. And I think something like 400 groups that we'll be actually doing initially in our official node map test. And then after that, we're going to be iterating and growing that. So the LNet routers that we will use to bridge into that cluster as it comes into production in the current facility, we'll have that node map enabled. We'll be matching existing users based on their email addresses, because while a lot of users complain about having an account in both places, some have gone through the work and done that, especially if they want like an allocation on Delta, which is an NSF allocated system. Some of the University of Illinois faculty will apply via Access, formerly Exceed, to get onto that system, and so thus they'll have an NCSA account. So we want to map users that already have NCSA accounts to their Illinois identity. So we're going to have to map that as well. We're going to match based on email address, and that way, and also, so for Illinois users that don't have NCSA accounts, we're actually going to have to silently create an NCSA account for them that they don't know about until they happily log in one day and find out they do have an account, if they ever were to. And then we'll check this probably every 15 to 30 minutes. We're trying to figure out how aggressively we want to keep this node map up to date, what's reasonable, and how that interlocks with everything else that we do. And we're also obviously keeping this node map configuration external to the file system as well, so we can repopulate this node map if we were ever to need to. I'm talking with Andreas about this a little bit at SC about how node map is controlled and configured on the system. So we're going to maintain all of our mappings in the state of all of them outside the file system, and then inject them live every time we do an upgrade. The big goal here is to maintain this paradigm that we started with the Taiga file system, where users on any system can access data on it from wherever they are on another system and not have to transfer data back and forth. It's just we're having to do a lot more work now because we're having to merge two different identity realms together. But we still want to have that dream available for users where it might be a professor that has an allocation on the Illinois campus cluster because they bought into that. That's a paid model, but then they might have an access allocation on Delta or Delta AI, and they might be running pipelines simultaneously on both and accessing data from both at the same time. And so we want to kind of try and maintain that, and then hopefully not have to worry about the man behind the curtain making that magic happen. So that's a big project that's actively underway here this summer to get that finalized. We're also opening up access to Taiga via S3 here pretty soon. So essentially S3 came up in Peter's talk as well about access via S3. We run, unrelated to Lustre, we run VerseD, ScoutAM, ScoutFS for our tape archive system. And they have put out an open source S3 client. I think they work with Lanel and Posse on this. But while they obviously want you to set it up in front of their product for obvious reasons, it actually supports any backend POSIX gateway. So they essentially did it because MinIO made their change to how they do their NAS gateway. And so VerseD kind of said, screw it, we'll write our own. And they did. And so we're actually, so far it's been working pretty well. We've been in good talks with them as well. And we've actually been testing on Lustre as of last week. And it's been working pretty well so far. We haven't been able to totally break it yet. We have submitted a couple PRs for some feature tweaks for it. But yeah, we're actually testing that for users. This will be on a as needed basis. We're not going to just open this up or by default provision it, but especially for people who want to ingress or egress data via S3, we want to have that available to them. We see a lot of times researchers, especially we have a large agriculture department, they operate a lot of sensors and drones and things what we might call at the edge, to use the flashy industry term. A lot of those tools that they use like to talk S3. And so we want to be able to ingest data from them, make that easy for them to ingest. Because a lot of their instruments will have literally a cell phone modem that will be uploading files every so often. And they like to just do that via a put, and put files up that way. Also for data sharing activities, a lot of, in our OpenStack environment, a lot of researchers spin up science gateways. We do a lot of work with the Science Gateways group, and a lot of them like to use S3 as their protocol for data dissemination and data sharing. So we're making that open to them there as well for that. So Taiga's right now through the midway of its life cycle. We're giving the talk on it here about halfway through its life. So we're slating for an upgrade in 2026. So we're obviously keenly watching things. The prior talk actually was very interesting about what ClusterStor is doing with data management and tiering there. So we're trying to figure out what we want next in our next generation, or we're calling Taiga Next file system yet. And so we're hopefully going to start working on that in 2025 with the deployment hopefully landing in 2026. But our hope is that we kind of maybe look towards all flash if prices don't keep going up. But that's kind of where we're looking to go, because right now Taiga is kind of positioned as the projects file system for our center. But we're actually looking to kind of increase its scope to not just be a project-based storage, but essentially all active data. So if data is active, it sits on the Taiga file system. If it's not active, it sits in the tape archive. And we're all computer people, like that binary state. Data is either active or it's not, and we kind of put those two things in those categories. But we will see that's kind of where the future of the system is headed as well. So maybe in like 2026 or 2027, I'll come back and give another update on what we end up going with here for that. But I also wanted to touch briefly here on the largest Lustre file system. Taiga is our largest, I guess, technically by capacity, but our fastest file system here, as we bring Delta AI in here, we're about to bring in 10 exascalar 400VX2 units to augment 3 existing 790X units and bring those together. Being an AI system, the Delta AI is slated to be, obviously small files, is very much in our mindset. We'll be running 40 MDTs on that system, scoping for about 30 billion inodes of capacity. And we're playing with where our max round robin inherent depth will be, 5 or 7 levels. We're still trying to tease out how deep we want to go there. We're actually merging the existing Delta file system, which is those 3 7990X units, into this file system, and then just leveraging PFL to allocate data to the correct appliance. This will give all the capacity the same metadata performance effectively. We're not going to, the 7990X units do have some SAS SSDs for metadata now, but it'd be much better to get all the metadata into those 400VX2 units across 40 MDTs, and then we'll just let PFL. And we'll be leveraging pool quotas for the first time here in the next couple months to control allocations for people to get data on different pools, which is also why we're not going to be running DOM there, I think, as well for that. So, and I think that is my last slide. Hopefully, I didn't go too long.
You mentioned transitioning Lustre from project to project. What? Oh, sorry. Patrick Farrell from Oracle. You mentioned transitioning Lustre from project to project in Scratch. Sorry if I missed it. What do you use for Scratch today?
Usually distinct separate file systems. It might also be Lustre in certain cases, but it's usually just it's a separate area that is allocated separately. It might be purged in a different way.
So like ephemeral file systems?
Yeah.
Okay.
Yeah.
Thank you.
No.
Hi, Andreas Dilger, WhamCloud. When you picked your PFL sizing, did you do any kind of analysis on your file size distribution to pick, good part?
Yeah. We were migrating a lot of data off of GPFS file systems at that time, and so we used the policy engine there to we put files into buckets based on size there, and we use those bucket analysis to kind of figure out where we wanted to set those levels at for those levels. Yeah. We did have we're doing that again for Delta and Delta AI actually. On that last file system I just mentioned, we're actually running that analysis right now on Delta's Scratch file system to see what our file size layout is. We're trying to figure out how we want to stripe on all NVMe tier, especially that we're bringing in for Delta AI. So we're actually running that scan now for another time. Yes. Yeah, we definitely try to inform with that as best we can.
On top of that question, John Fragala, NVIDIA, are you evaluating self-extending layouts or pool spillover to further protect against if Flash unexpectedly fills up to not have a PFL error out?
We are looking into spillover for that. We haven't done testing with self-extending layouts or anything with that nature yet. Not that we don't want to. We guess we haven't had the cycles to do that yet. We do monitor our pool fill levels very closely, and at least I guess thankfully for us, our user community is not the super large, like DOE scale level of like Checkpoint where you can write out 4 petabytes while you go to lunch or something like that. So it's easier for us to catch those pool fills faster than we can usually. So far, and I'll knock on wood somewhere if this podium has it in it, but we so far been able to stay ahead of that with our monitoring to make sure we don't fill pools. But we are exploring spillover just in case something happens, because all it takes is one user being fun, right? So,
JD, quick question. So in the last slide, you were talking about combining the Delta AI. Was that going to be where would you purge all data and then rebuild it, or you were going to merge these together and have either some restriping operations or some other modifications to existing data?
that's a great question. That was a topic of a meeting yesterday. But yeah, no, the plan is currently to merge them, and we're going to have to, we're going to try and keep the data when we do that. And there'll be some LFS migrating that happens after that happens to make that happen correctly. The way the Delta is laid out, technically speaking, actually, is those 37990X units are, 2 of those units are scratch, 1 is home. We're actually moving to a global home file system right now. So that unit will get freed up and brought into that existing MME pool, which will give us enough capacity there to do the migration initially. And then we will add those 2 7990Xs in, and then we'll do a final LFS migrate to get that actually all striped out correctly. Users are probably going to get bonus NVMe space temporarily as part of that, just because the way the capacity is going to have to work out. But yeah, well, that is our plan, is to keep that going, which right now that file system, while small by many standards, there's 1.6 billion inodes in there as of yesterday. So it's not a tiny in terms of inodes. We're going to have to sync all that over, and that'll be a fun time. But yeah, that is the plan right now, is to not purge. So it'll be fun. Yeah. So.
Dominic Manolano, great talk.
Yeah.
Thank you. In terms of the Versity Gateway, did you modify the security protocol at all, or did you just kind of use what they provide?
So far, I've been using what they've provided.
Okay.
We've been working with them, adjusting on things like timeouts and things like that. They weren't initially conforming with the AWS spec for timeout, which we noticed. But they just fixed that, I think, last week. So,
okay.
But yeah, on security so far, it's the default right now. So.
Okay. Happy to collaborate on that if you'd like.
Oh, certainly. Yeah. We can definitely sync up.